Hi students, this is an example of an arc length problem. This problem is quite similar to the one on the discussion board for this week. The only difference is the discussion board is worded more as a word problem, but the actual math that we're going to be doing here is very similar. And the function is actually quite similar as well. So what we want to do is we want to find the length of the curve y equals natural log of cosine of x, where x goes from negative pi over 3 to 0. Okay, and for your discussion board problem, it's very similar. It's just, it talks about, well, here at negative pi over 3, or whatever the number is where it starts, that's when time equals 0. And then when x goes to the other endpoint, that's when time equals 1. And the discussion board problem talks about a particle moving along a curve. But that's the same as if you ask how far the particle traveled, the distance it traveled, that's the same as finding the length of the curve. So this is similar, it's just got different numbers and a somewhat different function. Okay, so let's work on this. So the formula we're going to be using is the arc length formula. Arc length formula. Okay, and that one is capital L is equal to the integral from a to b, of the square root of 1 plus dy dx quantity squared dx. Okay, so the arc length formula is what we're going to be using here. But to use the formula, you probably don't want to do everything all at once because it can get messy. So what you want to do first is you want to calculate dy dx, just like I list in your discussion board problem. And then you're going to square that, then you're going to plug that in here and use a trig identity, and then finally you do the integral. But you know, when in the discussion board problem, time starts at 0 and time ends at 1. But you're really not going to be using time because the variable here is actually x. So you're going to be going from x equals negative pi over 3 to x equals 0 in this one. And then the discussion board problem has somewhat different numbers. I think it's, you know, pi over 2 and 5 pi over 6, but it's the same idea. Okay, so and when time equals 0, we know that x equals negative pi over 3. So that's actually going to be our a. So a is going to equal negative pi over 3. And then at the end of the particle traveling, x equals 0, so b is going to equal 0. So for our integral here, what we're going to have is actually, for this problem, we're going to have the integral from a to b, so that's going to be the integral from negative pi over 3 to 0. So that's x equals negative pi over 3 to x equals 0 of the square root of 1 plus dy dx quantity squared dx. Okay, so what we're going to do is first we're going to find dy dx. That's going to be our first step here. So we're using this y equals ln of cosine of x. Okay, so our first step here is just going to be find dy dx. Okay, find dy dx. Okay, so what's dy dx going to be here? Well, dy dx is going to be the derivative of ln of cosine of x. So ln of cosine of x is a composite function. It's got an outer function and an inner function. So we use the chain rule, and the chain rule says you take the derivative of the outer function, inner left alone, and then you multiply that times the derivative of the inner function. So the derivative of the outer function, natural log, is going to be 1 over. So it's going to be 1 over cosine. So here we're going to have 1 over cosine of x. But now we have to multiply this times the derivative of the inner function. So here our inner function is cosine, and recall that the derivative of cosine is actually negative sine. So we're going to have 1 over cosine of x times negative sine of x. Okay, that's just the chain rule, using the chain rule to find dy dx. Okay, and then what we have to do next is we have to simplify this a bit. So the negative sine of x is in the numerator, and cosine of x is in the denominator. So if I bring the minus out front, I have negative sine of x over cosine of x. But we can actually simplify this using a very famous trig identity. Remember that sine over cosine is actually tangent. Okay, so what we have here is our dy dx is actually equal to negative tangent of x. Okay? Now to use this formula, we need to plug in negative tangent of x into the formula. We're going to actually not just need dy dx, but we're going to need dy dx squared. Now that does not mean the second derivative. What that means is you take dy dx and you square it. Okay? Alright, so now we're going to find dy dx squared. Okay, so that's the derivative dy dx that we just calculated, and we're going to square it. So we have dy dx squared equals negative tangent of x parentheses squared. Now the thing about this is what this actually means is negative tangent of x times negative tangent of x. So that means the minus is going to cancel because there's 2 of them. So the 2 minuses cancel, and that ends up just giving us tangent squared of x. Okay, so dy dx quantity squared is tangent squared of x. So now that we have dy dx quantity squared, now we want to simplify the square root of 1 plus dy dx quantity squared. We want to simplify that expression. Okay, so that's what we're going to do next. So we're going to simplify well, it's called the integrand. And the integrand is what you have inside of your integral. Okay, so what we have here is inside the integrand, we have the square root of 1 plus dy dx quantity squared. That's what's inside of the integral, so that's called the integrand. Okay, and so what we have to do there is basically just plug in tangent squared of x for the dy dx squared, and then we're going to use a trig identity. Okay, so we have the square root of 1 plus tangent squared of x. Okay. Right, because that's what dy dx squared is, tangent squared of x. And then you want to use a trig identity. So you go to your formula sheet, not on the first page, but on the second page, and you look under trigonometry, and we're looking for one involving tangent squared. Okay, so looking here, we see tangent squared of theta plus 1 equals secant squared of theta. So ours is actually already in that form. I mean, the addition order is switched, but remember when you're adding, the order doesn't matter. So that's actually just going to equal secant squared. Okay, so this 1 plus tangent squared of x is actually the same as secant squared of x. So we have the square root of secant squared of x. Okay, and then the square root and the square cancel out. So we just wind up with absolute value of secant of x. Now, why is it absolute value of secant of x? Well, if you take the square root of a square, that ends up being an absolute value because the square makes sure it's always either 0 or positive. But now, do you have to actually write the absolute value? Well, looking through what they did on my math lab, I don't believe they bothered to write an absolute value. So So I guess technically you don't have to. All right, so we won't write the absolute value, so we'll just write it as secant of x. Okay, so that's the integrand, and now we're ready to go ahead and evaluate the integral. All right, so now we're going to evaluate the original integral. Okay, so the original integral was the integral of this thing. Okay, so the original integral was the integral from a to b, so that's the integral from negative pi over 3 to 0 of the square root of 1 plus dy dx quantity squared dx. Okay, but we just said that integrand, it just simplifies to secant. So we're actually just going to be doing an integral of secant of x dx from negative pi over 3 to 0. Now, fortunately, in our formula sheet, I believe we do have a formula for the integral of secant of x. So we don't have to do that. We can just look it up on the first page of our formula sheet. The integral of secant of u du equals ln of absolute value of secant of u plus tangent of u plus c. And as you can see there, the absolute value ends up showing up. But they actually it actually shows up after you integrate. But that kind of explains why we had an absolute value earlier. So it shows up here. So anyway, here, because instead of u we just have x, we're going to have natural log of absolute value of secant of x plus tangent of x. Okay, so we're going to have natural log of absolute value of secant of x plus tangent of x. And this is evaluated from x equals negative pi over 3 to 0, to x equals 0. Okay, and really the rest of the problem is just plugging in the numbers, subtracting, and remembering how to use the unit circle. Okay, so remember the unit circle is on your formula sheet as well. But first of all, let's plug stuff in here. So plugging in 0 into the entire function, we have natural log of absolute value of secant of 0 plus tangent of 0. Okay, and then we subtract the function evaluated at the bottom number. So that's going to be minus ln of absolute value of secant of negative pi over 3 plus tangent of negative pi over 3. All right, and that one also has an absolute value inside of the natural log. So that way we won't have to worry about having negative numbers. Those are all going to be positive. Okay, so let's start with the first one. So remember that secant is the same as 1 over cosine. So you might want to rewrite it as 1 over cosine just to make it easier. So we have natural log of absolute value of 1 over cosine of 0. And then remember that tangent is sine over cosine, so that's going to be sine of 0 over cosine of 0. And then we have minus natural log of absolute value of, once again, secant is 1 over cosine of negative pi over 3 plus tangent of negative pi over 3, so that's going to be sine of negative pi over 3 over cosine of negative pi over 3. Okay, and then the rest of it is just the unit circle. So if you already remember the unit circle, then this part should be pretty easy. If not, you can look it up on your formula sheet. So let's look at cosine of 0. Remember that cosine is the same as the x-coordinate, and sine is the same as the y-coordinate on the unit circle. So let me zoom in on our unit circle on our second page. So let's start with cosine of 0. Cosine of 0 means we're right here on the positive x-axis, and cosine is the x-coordinate, which is 1. So cosine of 0 is 1. So we have natural log of absolute value of 1 over 1 plus, well, what is sine of 0? Sine of 0 is actually 0. So that's the y-coordinate here. Okay? So we're going to have plus 0 over 1. All right, and then let's do the same thing, but we're going to do for cosine of negative pi over 3 for the second part. So cosine of negative pi over 3, remember that negative pi over 3 is just measured clockwise instead of counterclockwise. So positive pi over 3 is up here, which means negative pi over 3 is down here, and negative pi over 3 is the same as 5 pi over 3. You can basically just add 2 pi to negative pi over 3, and that gives you 5 pi over 3. And if you add 2 pi, that means you're right back where you started. Okay, so this is going to be our angle here, 5 pi over 3, which is the same as negative pi over 3. And for cosine, we're looking at the x-coordinate, which is 1/2. Okay, so we have 1 over 1/2 plus, this other one is also going to be over 1/2. And then what was the y-coordinate? So sine of negative pi over 3 is going to be the y-coordinate on the unit circle. So again, at 5 pi over 3, the y-coordinate is actually negative root 3 over 2. Okay, so here in the numerator we have negative root 3 over 2. And of course, if you have the unit circle memorized still, that makes it a lot easier. Or if you use a calculator, there are a lot of calculators like the TI-30XS where you can just type in a trig function like that and it'll give you an exact answer, which is really handy because then you don't even have to think about it. You don't have to worry about a unit circle. Okay, so anyway, for this first function we have natural log of 1 plus 0. So this is 1 plus 0, which is 1. And absolute value of 1 is still 1, so we have natural log of 1. And then for the second, if we're doing 1 over 1/2, we flip over the 1/2 and put it on the top. Okay, so it ends up being 2. It's 2 over 1, which is the same as 2. So we have natural log of absolute value of 2. And then we have a minus, which I'm going to bring out front. And we can see for this term here, there's a 2 up in that denominator and in that denominator, so those two are going to cross out. So we really just have negative root 3 over 1, which is the same as negative root 3. Okay? Negative root 3. And okay. So we're almost done with this. All we have to do is just simplify this a little bit. So when you look at the natural log of 1, remember that e to the 0 is 1. So that means natural log of 1 just becomes 0. And then for the negative natural log of absolute value of 2 minus root 3, there's not too much we can simplify here. Okay, so I took a little break and I thought about what I was doing here and I realized I made a mistake. Now normally I wouldn't keep this in a video, but I think this time I'm just going to go ahead and keep this mistake in the video and show you how I go back and fix the mistake. Because you're going to be doing this, if you're going into STEM, this is going to happen to you. So I think I'm just going to keep this in the video. So I did make a mistake here because I was looking at what my math lab did and they actually made a mistake in what they wrote. So back up here, we have an absolute value of secant of x, and I just kind of blew that off because my math lab didn't write it in their notes. I shouldn't have blown that off. That was a mistake. So this should be absolute value of secant of x. The reason it has to be that is because a square root of a square takes an absolute value. Now that ends up being important in this problem because you have this negative pi over 3 and that can be an issue. So what we got to do is we got to write it as absolute value of secant of x. Okay, which is a little strange, I know. And then how do you integrate an absolute value function? Well, it's still going to be natural log of absolute value of secant of x plus tangent of x. But the thing is, because you're integrating absolute value of secant of x, you're actually going to have to take the absolute value of this negative pi over 3. Okay? Well, when you plug it into the function anyway. So this is a little strange, but I believe we're actually going to have to take the absolute value of this secant of x and also this tangent of x. Okay? And yeah, I think that should do it. All right. So anyway, I'm doing it a little bit loosey-goosey. Loosey-goosey just means I'm kind of waving my hands a little bit and like, okay, well, we didn't quite get the right answer, so we need to fix something here. So the problem with this answer, I was looking at it, is you have a negative number at the end, and you can't have a negative distance. Remember, we're calculating an arc length, and you can't have a negative distance. So that's why I realized something was wrong here. I made a mistake. And I believe my mistake was not including the absolute value. So since we're integrating absolute value of secant of x, we're going to put absolute value around secant of x and also absolute value around tangent of x, even though there was already this inside absolute value. And I believe that's going to work. Right? And so, so what's going to happen here is I just have a bunch of absolute values now. Because all this stuff is supposed to be either 0 or positive. Okay, so let me put absolute values around all of it. Okay, and then over here, a big mistake that I made was having this be negative. So it didn't really affect anything until I got to the end here. So this is actually, when you take the absolute value of negative root 3, you get positive root 3. Okay? And also another thing about absolute values is they affect your limits of integration. So even though I'm doing this kind of loosey-goosey, kind of waving my hands a little bit, this x equals negative pi over 3, that's okay, but because we were doing absolute value of secant of x, if you take the integral of an absolute value, that has to be positive. So I'm not sure exactly how this happens, really. But this minus needs to be gone. Yeah, I'm not quite sure about it, but I do know that the distance has to be positive, so this minus has to be gone. Well, I did that one a little bit loosey-goosey. The one in your homework or on your discussion board, I think, is a lot more straightforward in many ways. But you can take it to the bank that when you have an absolute value, when you're integrating an absolute value, even though you have a negative pi over 3 here, the integral of an absolute value has to be positive or 0. But generally it's going to be positive because an absolute value is always 0 or positive. So the area under the curve has to also be 0 or positive. So I might not have done it exactly the formal way, but here this has to be positive because of the absolute value, and so do these. Okay, so then this absolute value at the end isn't doing anything though, because 2 plus root 3 is already positive. So we can write our answer as ln of parentheses 2 plus root 3. So, you know, I wanted to leave this in the video just so that you can kind of see some of the stuff that happens to people in STEM, where there's something that I'm not quite sure how to handle here. I do know that the absolute value integral has to be positive, though. So I haven't really studied integrals of absolute values in a long time, but I think it's safe to say that you should not have a negative distance at the end. So plugging in the absolute values, that did give us the correct answer, and taking the absolute value of our answer as well. Okay, so anyway, thanks for watching, and thanks for watching the mistake as well. That's just going to be part of the learning process. Those of you who go on to become engineers and physicists and mathematicians, there will be situations like this where you're not entirely sure what to do, but you realize that you can't have a negative distance at the end, so you kind of have to alter stuff and put it in a way that makes sense in the problem. But this actually is the correct answer according to my math lab, so we must have done something right with the absolute values here. Okay, thanks. Bye.